Next problem. Find the Fourier transform of f of x. If f of x which is equal to root 2 pi by 2 epsilon mod x is less than or equal to epsilon and 0 mod x is greater than epsilon. So we know that Fourier transform of f of x is given by Fourier transform of f of x which is equal to f bar of p which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x dx. So given f of x which is equal to root 2 pi by 2 epsilon when mod x is less than or equal to epsilon, 0 when mod x is greater than epsilon. So mod x is less than or equal to epsilon means x is lies between minus epsilon to plus epsilon. Mod x is greater than epsilon means x is greater than epsilon and x is less than minus epsilon. So other part of x lies between minus epsilon to plus epsilon, right? So which is equal to root 2 pi by 2 epsilon. So minus epsilon less than or equal to x less than or equal to epsilon. 0 otherwise, that is x is less than minus epsilon, x is greater than plus epsilon. So Fourier transform of f of x which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power I px f of x dx, which is equal to 1 by root 2 pi integral minus infinite to minus epsilon, because f of x is given f of x as the value in between minus epsilon to plus epsilon. The value is root 2 pi by 2 epsilon. So other part of this limits, the value of f of x is 0, right? So we are going to split the limit into 3, integral limit into 3. First part, so because we are starting from minus infinite to plus infinite, total a real line. In that real line, I am splitting the real line into 2, minus infinite to minus epsilon, then minus epsilon to plus epsilon, then epsilon to infinite, right? Because we are having a value of f of x only in the interval minus epsilon to plus epsilon, right? That is why we are splitting. So my integral minus infinite to minus epsilon e power I px f of x dx plus integral minus epsilon to plus epsilon e power I px f of x dx plus epsilon to infinite e power I px f of x dx, which is equal to 1 by root 2 pi. So integral minus infinite to minus epsilon e power I px here f of x value is 0 dx plus integral minus epsilon to plus epsilon e power I px, here f of x value is root 2 pi by 2 epsilon into dx plus integral epsilon to infinite e power I px, here f of x value is 0, right? That is what given, which is equal to 1 by root 2 pi integral. So 0 into something 0, so other two integrals vanishes, so we will get integral minus epsilon to plus epsilon e power I px root 2 pi by 2 epsilon dx, which is equal to 1 by root 2 pi. So root 2 pi by 2 epsilon is a constant, take it outside from the integration, integral minus epsilon to plus epsilon e power I px dx, which is equal to 1 by 2 epsilon, because root 2 pi and root 2 pi which is in the numerator and denominator get cancelled. So remaining you are having 1 by 2 epsilon. So we know e power ax, integral e power ax which is equal to e power ax by a. So here you are having e power I px, instead of a you are having ip. So e power I px by ip, so lower limit minus epsilon, upper limit plus epsilon, right? So that is equal to 1 by 2 epsilon upper limit, substituting the upper limit instead of x, e power I p epsilon by ip minus substituting lower limit minus epsilon instead of x, e power minus ip epsilon by ip. So 1 by 2 epsilon, ip is the common denominator, 1 by ip, e power ip epsilon minus e power minus ip epsilon. So 1 by, we are taking p epsilon, consider p epsilon as 1, 1 by p epsilon, remaining 2i, take it to the denominator of e, right, e power I p epsilon minus e power minus I p epsilon by 2i. So 1 by p epsilon into sin p epsilon, because we know e power iax minus e power minus iax by 2i, which is equal to sin ax, right? So we are using that formula. So you will get Fourier transform of f of x, which is equal to 1 by p epsilon sin p epsilon. Thanks.